Welcome back. After studying the second law of thermodynamics, we have in principle studied all the basic principles of thermodynamics. In the last maybe 9 weeks, we have studied work interactions, then the first law, the zeroth law, the second law. In between we took a detour to appreciate the properties of water and steam and use them in some applications and solve some problems based on them. So that was just to be comfortable with a working fluid like water and steam, a very common working fluid in real life and in particular in power plants. Now let us apply the first law and the second law to determine relations between properties of a given thermodynamic system. So our task now is to study property relations, thermodynamic property relations, okay. And we are going to assume, just for simplicity of the calculus, that we have a system which is a simple compressible system, or simple compressible means essentially a fluid system. Of course, we can apply it to solid, only thing is solid will not flow, and we will assume that the system is at rest. So we can replace the differential of energy dE by the differential of thermal energy du. The other components of energy will be assumed to be unchanged. Second thing is, we are going to assume a unit mass of the system, so that we can simply work with specific properties and mass will not be directly entering our expressions. Now what are the tools that we are going to use? First and foremost, the laws of thermodynamics. The first law, the second law in their proper mathematical form, and obviously what comes out of it is the basic property relation, which we have already seen, or the entropy relation. And we are going to use from calculus properties of partial derivatives and properties of exact differentials. In fact, this particular part of thermodynamics of our course is going to be perhaps the heaviest in terms of mathematics and in terms of calculus. Thank you.